This module will introduce you to some of the basic operations of the Ieubk. You will learn to enter information to predict risk and derive preliminary remediation goals, or PRGs. Exposure data used to run the Ieubk needs to be representative of current site conditions and any anticipated future use. Because of this, EPA recommends implementing a conceptual site model, or CSM. All environmental samples should be collected according to a site-specific CSM and data quality objectives, or DQOs.
A CSM, or conceptual site model, is a really important planning and organizational tool. It organizes the information that is already known about the site and helps the project manager identify additional information needed to calculate remediation goals.
The CSM also serves as a modeling, data interpretation, and communication tool. The project team may also use the CSM to direct fieldwork that focuses on the information needed to input into the model for a site-specific determination. EPA generally recommends that risk assessments conducted at lead-contaminated residential sites use the individual residence as the primary exposure unit if appropriate. This doesn't necessarily mean a risk assessment needs to be conducted for every yard, though soil lead contamination data collected from representative yards in the community, as well as other residential media, such as interior dust and drinking water, are used in the Ieubk model to establish preliminary remediation goals, or PRGs, for the affected residences. Let's review some terminology before we get into the details on running the model. MSD should be interpreted as the mass fraction of household dust that is derived from soil and a small contribution from air sources. PBD is dust lead concentration, and PBS is soil lead concentration. After launching the software and stepping through a disclaimer window, users are prompted to choose between beginner and advanced user mode. Beginner mode is useful for new users. If beginner mode is selected, the user is walked through a beginner wizard, which highlights the input parameter. For this training video, we'll use Advanced Mode, which allows experienced users to quickly move through the data input windows. Prior to using the Ieubk model, users decide on what analysis type to run. Each analysis type is appropriate for certain scenarios. Users can choose from Run the Model Single Run, Multiple Runs, Blood versus Media, Find soil lead concentration, and Batch Mode model runs. Run the Model Single Run allows the user to run scenarios for a single location or multiple locations with the same media exposures. The blood versus media mode is infrequently used for risk assessment, but may be of use in some scenarios, such as range finding or exploratory analyses. Multiple runs allows users to explore the impact of changing one media over a given range on risk for the selected age range. This can be useful in deriving preliminary remediation goals for a site. Find soil lead concentration allows rapid calculation of soil preliminary remediation goals. Batch mode model runs permits input data from multiple locations with different media concentrations in a single run. This is useful for calculation of risk in neighborhoods or communities with different exposure data for each residence, such as different lead concentrations in environmental media like soil, dust, air, water, diet, or other. Additionally, batch mode allows the use of different age children. The media intake and absorption parameters are the same for every exposure scenario in a batch mode run and must be specified unless default values are used prior to the batch mode run. The Ieubk model can also estimate indoor dust from outdoor soil. This is useful because EPA cannot always sample indoor dust lead. MSD is approximately equivalent to the PBD per PBS ratio at sites where soil is the predominant source of lead in house dust, that is, where there is no enrichment of the lead from paint. MSD should be interpreted as the mass fraction of household dust that is derived from soil. The MSD should only be used if the following assumptions are valid. 1. Soil lead is the major source of indoor dust lead. There is no lead-based paint contribution or other non-soil source, such as occupation or hobby. 2. The areas where soil samples are collected coincide with the major source areas for soil-derived indoor dust. If these assumptions are appropriate for a site and the exposure scenarios under consideration, then the site-specific indoor dust lead concentration can be estimated as dust lead concentration equals MSD multiplied by soil lead concentration plus a small contribution of lead from outdoor air lead at a 10% air lead concentration, where PBD is the indoor dust lead concentration and PBS is the outdoor soil lead concentration, and MSD is the mass fraction of outdoor soil in indoor dust. In other words, if you feel you have enough information to be confident in the MSD value, it can be used with the exterior soil concentration information to estimate the indoor dust concentration. Now let's see how site-specific bioavailability data is entered into the model.
The gastrointestinal bioavailability option allows the user to adjust the gastrointestinal absorption coefficient to adjust for site-specific bioavailability data of lead in the specific media. If this option is used, a disclaimer window will pop up that directs the user to ensure that the data they're using on site-specific bioavailability is scientifically valid and usable for the site in question.
Guidance is available from the TRW Lead Committee website concerning collecting site-specific bioavailability information for your site. We're now ready to run the model to predict risk. The Ieubk model can calculate 4 primary outputs. They are 1. Geometric mean blood levels by age. 2. Probability that children will have a blood level concentration greater than a user-specified level of concern. 3. Average media-specific daily lead uptake rates. And 4. Media-specific remediation or cleanup goals. By default, the Ieubk model generates a text file of the output unless a graph is chosen prior to running the model. Other output options include tables and graphs. Screen captures of graphs for use in reports can be generated by applying the print screen feature available on most PC keyboards, resizing the image to the appropriate dimensions, and then exporting the image to the desired application. Text files can also be exported to most statistical software packages for additional analysis. The Ieubk model incorporates output options that facilitate the presentation of risk assessment results. The graph pull-down menu includes blood lead concentration versus media lead concentration, distribution probability percent, distribution probability density, distribution probability for multiple runs, and probability density for multiple runs. Each of the output options allows the user to examine a different aspect of the Ieubk model simulation.
Output from a single simulation run can be displayed in many forms. Most users choose to view the variability associated with blood lead concentrations. This data can be displayed graphically or with a cumulative probability distribution. This allows the user to view the hypothetical range of blood lead concentrations predicted by the model in a single exposure scenario. Users may also wish to view the estimated probability of exceeding the blood lead level of concern.
This may be considered the best estimate of a plausible range of blood lead concentrations for a hypothetical child under a specific lead exposure scenario. The range of values is centered on the geometric mean blood lead concentration expected for a typical child with this exposure scenario. The portion of the upper tail of the probability distribution exceeding some chosen blood lead level of concern provides an estimate of the risk of exceeding that level for a typical child given that exposure history. The find mode of operation may be used to calculate a preliminary remediation goal for soil. First, enter site-specific information for all media, including bioavailability information. Then, open the Find window. Enter the variable values for age range and level of concern. Through iteration, the Ieubk model automatically calculates the highest soil lead concentration, or PRG value, that meets these parameters. For more information on the Ieubk model, please visit the websites listed on screen.